Okay, I just drew this shape right here, and what I want to do is I want to saw the three sides, but using a finger bit I want to do the arc. Okay, so I drew it, and by now you know how to draw, so I'm going to hit next, and all the arrows look correct. Next again. Okay, I'm going to split. Now I want all right. Now so far we've only basically been using a saw. Well, I'm going to leave this alone right here. I'm not going to change this to a finger bit or anything. I'm just going to leave it as disc, okay? And I'm going to hit next. By the way, let me take a second here and talk. I could make a group out of the three straight lines, and this way one operation would handle all three of those. And we'll talk about that later. Let's just go next and finish, right? Okay. So here's my part. I'm going to open this up. All right. Let's go to machining. Edit machining. Okay. So there's a straight line. There's a straight line. There's the arc. There's the straight line. Let's take the arc. Base machining. And again, as you know, we can change this name to my arc. Arc, whatever you want to call it. But I am not cutting with the disc. I'm cutting it with a mill. That's what they call on a finger bit, a mill, an end mill, okay? State, green check, I do want this. The depth, right. Now, I'm going to go to advanced data. Okay, so as we know, we can't take the 3 centimeters in one shot when we're cutting an arc. The gearbox is not meant to take that much of a cut. So we're going to subdivide this. So I'll put 5 times, so it's going to take 5 passes. Subdivide planes. So now, from the end of the part, it'll plunge down, cut, plunge down, and cut back and forth. Let's talk about the Z reduction. Okay? So first, make sure we understand. Subdivide, the Z-axis will go down, the machine cuts to the end, the Z-axis goes down, and it cuts. Okay? Z reduction, what that's going to do, I'm going to change this to an adaptive angle, factor of 0.5, and I'm going to explain that in a little bit, okay? Basically, now what's going to happen, okay, so I got adaptive angle and subdivide only on this. So now what's going to happen, as it's machining the arc, the Z-axis will be moving down at the same time, okay? Without Z reduction, the Z-axis goes down to a depth, makes the cut, down, cut. With the Z reduction, it's going to go, the Z-axis will be moving as it's making the arc. And we had a factor of 0.5, so the Z-axis will move down about 1/4 of an inch. Now, these three, that's being done with the disc. That's being done with the disc, and that's being done with the disc. So I'm okay there. I don't have to do anything. I'm going to hit OK. I'm going to go to Sort Machinings and set the cut directions. Okay, so I got 1, 2, 3, 4. Okay. Let's go to Build. ISO, compile, isometric view, and let's play this. Okay, so we're taking the 3 centimeters in one shot. One shot. Okay, so now we're using the finger bit. The z-axis is moving down as it's cutting. Okay, what I want to do, I just want to show you the program, okay? Alright, here's the G code. Obviously all this is for the beginning was for the disc. Okay, here we go. Here's the arcs, right? So G1 means a straight line, G3 is counterclockwise, G2 is clockwise. Notice here the z-axis, as it's making the arc, is moving down. See, 250, 500, 750. So what I have discovered is that that factor of 0.5 seems to equal a quarter-inch depth on the helical move. And I hope that answers some questions. Again, what we should have done probably is just made a group. I'll do something like that in a little bit here.